3, 2, 1. And liftoff of the Falcon 9 and upgraded Cargo Dragon, the first cargo capsule to dock to the International Space Station.
Humans have launched thousands of satellites into Earth's orbit to find out all the secrets of our planet from above. And from sending them for research purposes to understanding their functions and nature, the story of satellites marks a great revolution over time. Now, not to mention, those satellites have become absolutely crucial in our daily lives. We don't even realize how much we rely on them for navigation, phone calls, text messages, internet browsing, and weather updates. Their impact is ubiquitous in pivoting our lives in thousands of ways. However, since the first day of launching these satellites, mankind has also indulged in leaving debris into space. Since the time we started exploring space, consciously or unconsciously, we've been leaving behind a lot of junk up there. And most of us don't know the consequences that come as a courtesy with each satellite launch. Day after day, those junks are becoming a big problem. They are obstructing the way of our satellites and future space missions from orbiting spontaneously. Though Earth's atmosphere can clean up a bit of debris from orbit, mankind's produced debris is making more junk than its capability. And if we persist, space might get so swarmed with garbage that it will make it almost impossible to launch any more satellites into space. In fact, the existing satellites in that scenario will require evacuation to avoid destruction. Since the late 1950s, we've launched thousands of satellites into space. With the help of superfast rockets, we were able to put these satellites into orbit around Earth. They are constantly zipping around above us for years and doing the most crucial jobs that change the way we live our daily life. For instance, taking pictures of Earth to predict weather, sending phone, TV, and radio signals between places, or spying on other countries with military satellites. They are interconnected with every aspect of people's lives. These satellites are controlled from the ground and have computers, cameras, sensors, fuel, batteries, and solar panels to power them. Solar power backing it up means less requiring of fuel to start the engine. Terrific. Any idea how fast the space junk circles around the Earth? It's around 18,000 miles per hour. So whichever satellites come across those flying debris simply end up clashing and decluttering at instance. That's not all. These broken little debris then rise to more debris when colliding with other small particles or satellites in the worst case. Right now, there are almost 1 million things bigger than half an inch flying around up there. Well, the story began around 60 years ago. In the late 1950s, people realized that the future of Earth depended on space. So, during the Cold War period, the Soviet Union kicked off the space race by launching the very first satellite in the world, the Sputnik. One of the rocket scientists of the France National Center for Space said how the problem began.
The orbital debris problem started at the same time as the first launch on October 4th, 1957, with the launch of Sputnik 1.
After 21 days in space, Sputnik faced downtime. It became useless and turned into what we call space junk. Sputnik didn't last long and broke apart in the Earth's atmosphere 3 months after it was launched. Sputnik had a big impact worldwide. It made the Americans want to catch up with the Soviets in terms of rocket launching and satellite sending to space, so they formed NASA.
The Soviets' advance was extremely important to astronautics. The Soviets had all the firsts, the first satellite launch, the first person in space, and they raised the bar for the Americans, who had to increase their missions in order to catch up.
Following the Soviets' missions, the Americans sent 17 consecutive manned missions into space missions named Apollo. They even had a protocol called 180 degrees to prepare for jettisoning SIVB. Back then, leaving waste or even radioactive elements in space wasn't a big concern. Meanwhile, from 1967 to 1988, the Soviet Union launched a bunch of spy satellites powered by nuclear reactors. Unfortunately, some of those were malfunctional. In September 1977, American radars detected unusual movements from the Russian satellite Cosmos 954, which marked the first nuclear alert in space history. Following this, on January 12, 1978, American authorities reached out to the Soviets about the satellite. 2 days later, the Russians admitted they had lost control of it. When the satellite plummeted through the atmosphere, It spouted radioactive material across northern Canada. The incident heralded the portent danger of orbital debris that could be deadly to Earth's population during the tense Cold War era. But that's not all. Launching satellites into orbit also produces debris as a byproduct. Since the time the space race started, satellites were not the only items to be released into orbit. Rudiger Jen, a European Space Agency engineer, has analyzed the orbital debris and said,
"When they launch a satellite, the first stage of the rocket provides enough energy to go 10 kilometers in altitude, and then it falls back into the ocean. The last stage takes the satellite into orbit, but then it also stays in orbit itself and becomes debris."
For the past 6 decades, there have been tons of parts routinely sealed off in orbit. The upper stages of rockets, fuel tanks, and nose cones are the most common ones. Some of this debris has piled up over time as much as 60 years, while other bits have crumbled and are roaming around. Noelia Sanchez-Ortiz, a space researcher who collaborates with space scientists from the European Space Agency, studies the situation and said,
"We used to put objects in space, and we think that when it is not functioning any longer, we can leave them there. Therefore, it remains there unless it is very low, and it slowly falls down into the Earth."
At lower altitudes, space debris zooms through the sky at a staggering pace around 18,000 miles per hour.
However, as it descends closer to Earth's surface, the planet's atmosphere gradually slows down its pace. When these debris eventually make their way back to Earth, most of them meet their end. The rapid motion of the debris compresses the air molecules around them, which generates excessive heat. This heat causes the pieces of debris to break apart into smaller fragments. During the day, we usually don't notice this happening, but at night, the burning debris can sometimes look like shooting stars. However, sometimes some of these debris don't incinerate properly, left intact mostly, and can pose a significant threat to the inner atmosphere on Earth. In 1997, a 550-pound fuel tank from a Delta II rocket crashed near Georgetown, Texas. In 2001, the third stage of another Delta II rocket fell, scattered approximately 150 miles from Riyadh in Saudi Arabia. In 2011, the nose cone of a Soyuz rocket was discovered in Martinique. And in 2013, several titanium tanks from unidentified sources were found in the garden of an electrician in Texas. None of these incidents recorded any death or injury of any individual, but the question remains, will that always be the case? In September 2016, a part of a Falcon 9 rocket crashed into a building on a small island near Java. Sometimes, it gives an impression that the sky is really descending. Currently, there are about 20,000 objects orbiting in space. Only a small portion of them come back to Earth, while most remain up there because we don't have any force or robust technology that will push them down to Earth again. However, since we monitor all rocket launches, it's relatively easy to keep track of what's circling above us. In the suburbs of Earth, you'll get both active satellites and floating debris. But even in this mess, things tend to remain pretty organized. All the satellites only orbit around 3 main paths around Earth. The outermost orbit is the geostationary orbit. Positioned approximately 22,000 miles away, satellites within this orbit remain stationary above a designated point on the equator. They play a crucial role in maintaining telecommunications, facilitating phone calls, internet connections, and TV broadcasts seamlessly. Each satellite is typically placed about 40 miles apart to make the most of the limited space available. When satellites reach the end of their operational life, they use up their remaining fuel to move to a higher orbit called a graveyard orbit. Here, they're deorbited slightly to get further away from Earth to avoid causing any interference. Below the geostationary orbit is the medium Earth orbit, which spans from 22,000 to 1,200 miles above the surface. This area is the home of radio navigation satellites like GPS. If one of these satellites breaks down, it gets shifted to an intermediate orbit where it won't disrupt others. And the closest orbit to Earth is called low Earth orbit, which is located below 1,200 miles in altitude. Unfortunately, this is also where most of the space debris from the past 60 years of space exploration accumulates. The only way to clean up this area is by sending the debris into Earth's atmosphere, where it will burn time by time.
There are different areas on Earth where objects can re-enter with almost no risk because they are far from populations.
For example, there is an area in the South Pacific that is very big, and where we tend to re-enter large objects. Satellites can be maneuvered in low, medium, and geostationary orbits as long as they're operational and have fuel. However, sometimes satellites can lose control, even if they still have fuel left. The operators are often reluctant to discuss malfunctions because they don't want to appear less reliable. However, many failures occur due to natural factors. When we analyze the cause of these malfunctions, it can, for example, be a result of a solar flare. When solar storms occur, the sun releases vast amounts of energy and scatters electrically charged particles into space. Earth's electromagnetic field shields us from these particles and can only and often be seen during the northern lights. However, these storms are a threat to satellites. Additionally, solar radiation can mess up navigation systems. Notwithstanding these are safeguarded with advanced gold foil, approximately 12 satellites succumb to damage each year by solar flares. And this scene also contributes to the increasing amount of space junk. Space is an infinite empty space with some junk, some debris that is moving about up there, and unfortunately, that poses two significant problems. First, when they are up there, they're there for a long time. An object at an altitude of 600 miles, for example, will stay there for 1,000 or 2,000 years. Second, because they are in orbits, they are moving at speeds of 18,000 miles per hour. So the probability of crashing into something during that time is actually quite high. Until 2007, experts kept track of about 12,000 big chunks of space junk. But two incidents made things worse after that. One involved a Russian satellite called Cosmos 2251, which malfunctioned suddenly while in low Earth orbit. The Russians couldn't control it anymore and couldn't bring it back to Earth. At the same altitude, there was a new American satellite called Iridium 33 in a different path. When they crashed, they sent debris flying everywhere. About 1,000 pieces larger than 3 inches and thousands of smaller bits were scattered into space. And this accident caused a big threat to all the other satellites in low Earth orbit. This collision showed that a satellite going out of control in low orbit can turn out deadly for all the other satellites that are working properly. Another event, sounding like something from a Star Wars movie, happened when China decided to intentionally destroy a weather satellite that was non-operational for some time. They used a ballistic missile with an infrared seeker and a warhead to destroy it without thinking of its ramification. All happened out of China's irresponsible act and boasts.
Everybody talked about this Chinese event as a test to demonstrate that it is possible to force a collision. It was made on purpose, and it was the main cause of the current risk we have now.
As a consequence of these two incidents, by 2010, there were over 17,000 big chunks of debris orbiting Earth. Some of these fragments didn't come from satellites, but from rockets. In the fuel tank of a normal rocket that takes satellites into orbit, you have one chamber with liquid oxygen and another with liquid hydrogen. I'm sure you remember from school that when these two gases mix, they become nitrous oxide and it explodes. That's what happens again and again in space. Not all the fuel is used to the last drop. This reserve fuel mixes, and instead of having an intact upper level, you have 1,000 pieces of debris that remain in orbit. Similar to a pandemic, this space junk multiplies and could lead to even more debris. It's called Kessler syndrome, named after the NASA consultant Don Kessler, who first described, analyzed, and quantified it.
We currently have enough objects in Earth's orbit. Once every 10 years, we expect 2 objects to run together and create a major breakup.
He proposed the scenario back in 1978. Since then, it has been proven multiple times. Take the Cosmos-Iridium collision back in 2009, for instance. Roughly every 5 years, collisions between sizable objects and their fragments are expected to result in further debris. Don Kessler also said that when things crash into each other in space, it could start a chain reaction known as the cascade effect. This means that each crash makes it more likely for more crashes to happen.
The issue becomes when this happens, an object can come in and hit the satellite and produce a spray of particles that are very numerous in number for the smallest particles that those can go on, and because they're traveling so fast, can damage spacecraft. Then you also produce about 100 big enough fragments that will go on and hit another satellite in the same way and break that satellite up. Therefore, you have this slow, cascading phenomenon going on.
This theory was proven true in 1996 when debris from an Ariane rocket, launched a decade earlier, crashed with a French military satellite named Ceres. This collision damaged a 10-foot stabilization boom on Ceres, causing it to lose control. And just like that, the chain reaction continued. All the non-working satellites and leftover rocket parts have formed clouds of debris. They crash into functioning satellites and create even more debris. This increase in debris could pose a risk to many activities on Earth. It's easy to forget how much we rely on satellites in our daily lives.
We expect to open our mobile phones, look for a place, and ask our mobile phones how long it will take us to go there and which is the best way to go there. On travelling, we take money from a bank. We are using telecommunication satellites to communicate this bank in maybe America to our bank in Europe.
It's difficult to picture life without smartphones, bank cards, or GPS systems. Yet, the increasing amount of space debris puts today's wide range of satellite services at risk. That's why all space agencies, including the European Space Agency, have to carefully measure the ratio and probability of the dangers every time they launch something into space.
If we are waiting for a situation where our uncertainty volume is completely empty, that would mean we could never launch. Therefore, believe it or not, we are launching despite the possibility of having conjunctions with objects, because otherwise there would never be a green light for launch.
The risk is now proven and even quantified.
The odds of losing a satellite are 5%. Part of it is the risk of being hit by debris. The other parts are simple. There is complicated hardware that can break, causing the satellite to be lost. But the likelihood of losing a satellite can quickly reach 10 or 20% with the increase in orbital debris.
The European Space Agency predicts that the chance of satellites crashing will increase to 20% by 2038. This means that 1 out of every 5 satellites might not be able to finish its job, which is a significant number. To navigate this challenge and detect the orbiting debris, space agencies have had to come up with solutions. Since 1957, the United States has been keeping a sharp eye on the movement of space junk entering Earth's atmosphere using a space surveillance network. They've built a catalogue of this debris to determine its ownership and warn other agencies like NASA if their satellites are at risk of coming in contact with debris. Over time, this system has become more advanced and computerized. In Europe, a similar system wasn't established until much later. In 1996, after debris from an Ariane rocket damaged the military satellite Ceres, the French Ministry of Defense created a system called Graves to monitor space debris.
The Graves system, a space surveillance network, is the main sensor that allows us to detect objects that orbit around 250 to 600 miles in altitude, as long as they are large enough to be detected by radar. In other words, if they are the size of a large washing machine.
France agreed to keep the discovery of the spy satellites under wraps, but they struck a deal with the Americans. In exchange, they requested access to the American catalogue of orbital debris. The American catalogue is much more detailed compared to the European one, as it can detect objects as small as 4 inches. This ongoing surveillance of space is effective and allows both civilian and military satellites to avoid collisions with space junk. If there's a risk of collision, operators on the ground can adjust the orbits of their satellites slightly. These adjustments are becoming more frequent, especially for the International Space Station, the largest satellite ever built. This manned satellite faces threats from debris multiple times a year. To avoid debris with a predicted path, the space station occasionally needs to alter its route. In 2012, the space station managed to dodge a chunk of debris from the Iridium and Cosmos satellites' collision 3 years prior. By 2021, the station had to steer clear of flying debris 5 times. This ongoing threat has become a normal part of the astronauts' daily lives. In cases where the data about debris is uncertain, astronauts are instructed to evacuate the station immediately as a precaution. They seek refuge in the escape module, which can detach from the station and return them safely to Earth. However, evacuation is not needed every day. Often orbital debris smaller than 4 inches goes undetected. Nowadays, millions of tiny pieces of junk cannot be tracked by the radar, despite their sheer advancement. To mitigate this threat, satellites and the ISS need to be shielded. In Freiburg, Germany, scientists at the Fraunhofer Institute are testing shielding materials using a super-fast accelerator called a space gun. This device shoots tiny metal balls at various materials to simulate collisions in space. These chambers replicate space conditions by filling them with light gases and propelling the balls at the same speed as orbital debris. At such high speeds, collisions behave very differently from those on Earth, like car crashes. When a car hits a wall at 30 miles per hour, it deforms and creates thousands of fragments. However, in hypervelocity impacts, which exceed 6,700 miles per hour, the collision generates a unique physical occurrence. In hypervelocity collisions, particles are fragmented, vaporized, and ionized. The immense pressure after the shockwave is too much for the materials to withstand. To put it in perspective, a 1 millimeter ball at hypervelocity has more energy than a baseball traveling at 60 miles per hour. To ensure safety, reinforced doors protect the laboratory, and no one is allowed in the room when the space gun is fired. The high-speed camera captures over 1 million frames per second and records the impact. Afterwards, scientists analyze the results of these tests on various satellite components. For the International Space Station, we tested several shields, but we also tried to test the components like space solar cells or components like tanks, which are located behind the walls of a satellite. Using ultra-slow motion images, the space gun team can analyze and replicate what happens during a collision. Their research helps them design structures that are lightweight yet strong enough to withstand hypervelocity impacts. By adding multiple insulation layers, they've shown that satellite components can be protected from debris smaller than 4 inches. The first layer breaks down the debris, while the second absorbs its energy and shields the third layer. Thanks to these experiments, scientists have developed satellites that can endure impacts from small debris. However, astronauts remain vulnerable during spacewalks, as they're exposed to fast-traveling debris that radars can't detect and the human eye can't see. Even a tiny collision could damage an astronaut's suit, which will lead to an instant death. To avoid this type of risk, NASA is working on developing robots to perform maintenance tasks outside the spacecraft instead of humans. However, these robots wouldn't be able to withstand collisions with debris larger than half an inch. Therefore, reducing the amount of debris in space is crucial. Countries worldwide have attempted to establish regulations to prevent the proliferation of large debris, similar to those for land-based nuclear weapons. For instance, satellite operators are required to remove all fuel from their spacecraft before launching them. Rockets are equipped with systems to vent or burn off excess fuel, which is tested before every launch. Satellites are also limited to a maximum lifespan of 25 years in orbit. Finally, objects in low Earth orbit that don't completely burn up upon re-entry are directed towards large ocean areas for safe disposal. Unfortunately, these regulations aren't always followed, especially since there's no governing body to enforce them. As time goes on, the amount of space junk continues to increase. According to the polluter pays principle, each country is responsible for funding the cleanup of its own space debris. Since 2013, space engineers have been tweaking on a new profession, the space garbage guy. The goal is to develop robotic systems capable of handling large pieces of space junk by sending them into the Earth's atmosphere. However, it's a challenging task because orbital debris moves unpredictably, much like an asteroid orbiting Earth due to gravity. Around the globe, laboratories are working on creating robot satellites designed to capture debris and safely remove it from orbit. One such initiative is the Remove Debris Project, headquartered at the Surrey Space Centre in England. Their team is dedicated to finding innovative solutions to tackle the growing problem of space debris and ensure the safety of space exploration in the future. Space engineers used uncountable technical terms, but their projects seem more like children's games. It doesn't seem likely that the team is making a harpoon to grab onto space junk and pull it down to Earth's atmosphere. Using a harpoon might sound strange, but it's actually a clever idea to solve the problem of cleaning up space junk. The team wants to create a harpoon that can grab onto the junk securely and guide it back down to Earth. This way, the junk can burn up and disappear safely in the atmosphere. The team is currently in the experimental phase, where they're testing a small harpoon on a stationary target. During the first try, the harpoon didn't come out of its holder because of an electromagnetic issue. For the second attempt, They hoped the harpoon would hit the target exactly where they aimed. Again, it failed once more. If the harpoon doesn't hit the center of the target, it won't be able to grab onto it. Despite these setbacks, the team is determined to keep testing until they find a solution. They're working hard to make sure the harpoon can capture space debris effectively in future attempts. According to scientists, hunting debris should be easier in space than on Earth. Using the trial and error method takes time, but the team is making progress little by little. The first big tests in space were held in 2020, but the harpoon wasn't the only idea that space engineers were considering. The South African Space Agency, established in 2010, has also developed its own solutions for cleaning up space junk. They plan to sell these solutions in the future. One of their projects is creating a small satellite called Medusa. It has special tentacles that can unfold and grab onto debris. This unique design allows it to capture space junk effectively, hence the name Medusa. Another good thing about Medusa satellites is that they can be launched straight from the International Space Station. A CubeSat is a tiny satellite shaped like a 4-inch cube, created by a university in California. What's great about CubeSats is that you can launch dozens of them at once, which makes it cheaper. This is really helpful for researchers who want to do experiments in space, but don't have a lot of money. When combined with CubeSats, Medusa could help get rid of space debris over the next 25 years. However, there's a downside to Medusa. It can only deal with small space debris. For larger, non-working satellites, we need different tools. But funding these operations is a challenge. The problem with big debris is that it can cause even more issues. The largest non-working satellite is called NVSat. It's as big as a bus and was launched by the European Space Agency in 2002. Back then, they wanted to make the most out of their investment. But now, Rudiger Jen, who works for the agency, is distancing himself from what his predecessor did.
They just want to maximize the revenue. They use the last drop of fuel for their operations, rather than using the fuel for deorbiting, and this is the problem.
When NVSat was constructed, it marked a significant milestone as the largest observation satellite ever developed. Over 5 years, it completed an impressive 50,000 orbits around the Earth. Though it was intended for deorbiting after this period, the mission was extended. However, 10 years following its launch, the European Space Agency encountered a major setback. On April 8, 2012, all control over NVSat was lost. Now it remains a significant threat as it intersects with numerous operational satellites.
We believe that throwing a net could be an option, because throwing a net means you will later have a connection by a tether, and that means the captured NVSat inside the net can be pulled.
To test this space net, engineers use an aircraft to simulate zero gravity in space. At the top of its flight, it releases objects for a few seconds of weightlessness. They test a small version of the net designed to catch an 8-ton satellite. By adding weight to the net's corners, they ensure it can cover the satellite without damaging its solar panels. Now, they need to make a tractor satellite to bring NVSat back to Earth. NVSat is heavier than the removal vehicle. Pulling is better than pushing when dealing with heavier objects. Although it is very important for space safety, this project is still mostly on paper.
We have investigated the problem to look for a solution, but it would cost €500 million.
For technical and economic reasons, robot garbage collectors are still not deemed ready for carrying out the operation at this time.
For this to become workable, the cleanup operation would need to be free, as if it were a passenger on another mission. What seems to be quite promising is what we call space tugs. On Tuesday, it would repair another. On Wednesday, it would inspect a satellite. On Thursday, it would do maintenance. On Friday, it would return to Earth, and it would gather up a piece of space junk and send it into the atmosphere.
But Airbus engineers working on space tugs say there are still some technical issues. A space rendezvous is a planned and managed encounter between two spacecraft.
We need to develop new autonomous technologies that can manage on their own. They would be based on vision sensors that would scan the environment and analyze the contents of the images they acquire. This data analysis will detect the parts of the objects that interest us in order to be able to catch them and manipulate them.
The Space Tug project is still under review, but with significant funding, the first effective cleaning service could be operational by 2025. Apart from the European Space Agency and Envisat, space tugs are attracting other clients. Plus, so many startups want to send lots of satellites into low Earth orbit to make a worldwide broadband internet system. These projects, called mega constellations, became a reality in 2017 with the OneWeb project. A visionary entrepreneur persuaded major internet companies in America, along with European Airbus, to invest heavily in building nearly 1,000 satellites.
OneWeb has designed, is building, and will soon be launching a constellation of satellites to bridge the digital divide and provide high-speed broadband access to half of the world, the 4 billion people without access today. In the first group, we plan to have 882 satellites. That's almost the same number as all the satellites currently up there, which worries experts who deal with space junk. There are many new mega constellations being proposed. There's OneWeb. We're not talking about 100 satellites. We're talking about 1,000 satellites that are about to be launched. Boeing and SpaceX. There are so many players on the market who have new ideas and want to launch satellites. In the end, it will all be space debris, so that's a big problem. Where is all this going?
However, the people behind these big projects say they've done everything needed to be careful. To address the growing threat of space debris, there's a pressing need for coordinated efforts on a global scale. While there's a growing consensus among space exploration enthusiasts about the importance of regulations, the lack of a centralized authority to enforce them poses a significant challenge. It would be great if the United Nations could lead the way in making rules and systems to manage space debris. By making those responsible for creating debris clean it up, we'd encourage better behavior in space. But until we actually do something about it, the danger from all this space junk stays high, especially for the folks who operate satellites and need space to work properly. Most people don't really know how serious the problem is, but if we don't act soon, it could start causing problems in our everyday lives.